working on section 4.5, which is point slope form. So it's similar to what we worked on in the last section, but it's just a different form of saying the same thing. So point slope form of an equation of a non-vertical line with slope m and point x1, y1 is y minus y1 equals m times x minus x1, okay? Now the important thing to remember is that this y, nope, we are in line mode. So this y and this x stay as x and y. You don't plug anything in for them, okay? So for this first equation, or for this first example, it says that a line passes through the coordinate point -3, 6 and has a slope of -5. What is the equation of the line? So this is the coordinate point I'm given, so we could label this as x1 and y1, okay? And it says that my slope, which is m, is -5, so I'm just going to plug in. So my original equation says that y minus y1, which is 6, equals my slope, so -5, times x minus x1. Okay, and I'm just going to clean this up a little bit. So we get y minus 6 equals -5 times x plus 3. And this is the equation of the line in point slope form. Okay? So I want you to try that same one on the next one on your own in the same way. So if we move on, this next problem wants us to graph the equation y minus 1 equals 2 over 3 x times x minus 2. So if I write the original point slope formula, I get y minus y1 equals m times x minus x1. So I'm going to pull out my points. Now I know that m is what's multiplied to this x minus 2 right here. So m is 2 over 3. And my point is going to be x1, y1, which is 2, 1. 2, comma, 1. So the way that we can graph this is we first graph this coordinate point 2, 1. So we go to the right 2, up 1. Okay? Now I use this slope. This means up 2 to the right 3 because they're both positive. Okay? So I go up 2, 1, 2, and to the right 3, which is right here. Okay? Now you could use those 2 points to connect a line, but I like to go the opposite way just so I have more coordinate points to work with. So I go down 2 to the left 3. Down 2 to the left 3. Okay? And then what you can do is, whoops, you can connect that line. And then it is drawn. Okay? So we like to always draw arrows on the end because it goes on indefinitely. Okay? So you guys, oh no, we're moving on together. Okay? So the next problem wants us to now take the drawing, the graph of the line, and find the equation. So you guys could count the slope, or you could calculate the slope using the slope formula using these 2 coordinate points. So that's what I'm going to do. So I'm going to label this point as x1, y1, and this as x2, y2. Okay? So my slope, again, is y2, so -3, minus y1, which is 4, divided by x2, -2, minus x1, which is 1. So when I simplify, we get -3 minus 4, that's -7, divided by -2 minus 1, -3. So this simplifies to a positive 7 over 3. Okay? So now I have my slope, and all I need is another point to plug into the point slope formula. So I'm going to use the point 1, 4. Doesn't matter which point you choose, but I'm using this point right here. It's cleaner numbers that I like better. So we get y minus 4, because that's our y value, equals our slope, 7 over 3, times x minus our x value, 1. And that's the equation of this line in point-slope form. Okay, we have one more problem to do together, and you're going to do the next one on your own. So this example says that the table shows the altitude of a hot air balloon during its linear descent, meaning it's coming down. What equation in slope-intercept form gives the balloon's altitude at any time? What do the slope and y-intercept represent? So we need the slope, right? So the first thing that I'm going to do is find the slope given using these two coordinate points. So 10, 640, and 30, 590. So my slope is 590 minus 640 divided by 30 minus 10. And this gives me a negative 50 over 20, which simplifies to negative 2.5. Okay? So now what I'm going to do is plug in this slope with one of these coordinate points into point-slope form, and then we're going to mold it into slope-intercept form. So I'm going to use this first point, 10, 640. Okay? So we're going to have y minus 640 equals our slope times x minus 10, because that's our x value. Okay? So now, slope-intercept form is when our y is alone. So I'm going to distribute this negative 2.5, and then we're going to move this 640 over. So first we get y minus 640 equals negative 2.5x plus, because it's negative 2.5 and negative 10, so we get plus 25. Last step, we want to get y alone for slope-intercept form, so we add 640, and we get that y equals negative 2.5x plus 665. Okay? Now, what do these numbers mean? That's the last part of our problem. So this first number, this negative 2.5x, well, this is our slope, right? And in this case, our slope is telling us how fast or how many meters our hot air balloon is descending in 1 second. So we're going to label this as the rate of descent in meters per second, because our time is measured in seconds. Right up here, seconds and meters. Okay? Now, lastly, this 665. This is my y-intercept. Now, what that means in the context of this problem is our starting value. And in this case, we're starting our hot air balloon high in the air. So we can call this the initial height, or that's supposed to be a slash, height or altitude, because that's our y-intercept. So our initial height or altitude. And all you guys, I'm asking you to do next is to complete the last problem on your own. So let's quickly show that. So you guys are going to do the same thing here. You guys are going to write this equation in point-slope form, and then you want to represent what the slope, you want to say what the slope is representing. And that's about it. Have a great night.